Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fatiha binti Bahrom, and today I would like to present my final year project titled LTE-based passive forward scattering radar for human daily activities detection and classification. First of all, for introduction, there are two types of radar system, which are monostatic and bistatic radar. For monostatic radar, the transmitter and the receiver are located at the same place, while for bistatic radar, the transmitter and the receiver separated by a distance comparable to expected target distance. We move to forward scatter radar (FSR). FSR is a special mode of bistatic radar. As illustrated in the animation, you can see the target, which is a human, will pass through between the transmitter and the receiver with bistatic angle equal or near to 180 degrees. Next, move on to passive forward scatter radar. In passive forward scatter radar, I use the LTE signal as a transmitter and passive radar as a receiver. And in my project, passive forward scatter radar was used to detect humans with various movements when passing through the transmitter and the receiver. Moving on to my problem statement and objective. My first problem statement is human trafficking, followed by illegal entry of person into the country, and border protection is not secure. As you all know, there's a lot of incidents involving human trafficking and intruders crossing Malaysia's border. For example, incident that happens in Lahad Datu and Malaysia-Thai border. Next, the objective: to investigate the forward scatter radar system shadowing of human movement in daily activities, to detect the presence of human Doppler signature with movement of daily activities, and to prove that human Doppler signature produced by different individuals of various size and shape is unique. Next, move on to the second part of my presentation, which is methodology. My first methodology is experiment site. As you can see, there are three locations chosen to carry out the experiment. First, we go to Kampung Nyalas, Melaka. For your information, Kampung Nyalas is a village area. The distance between the transmitter and receiver is 531.22 meters. Next, we go to Maeps. For your information, Maeps has the shortest distance between the transmitter and receiver, which is 176.78 meters. In addition, Maeps provides wide area for us to carry out the experiment and provide strong LTE signal. Lastly, we go to Teluk Kemang with the distance between the transmitter and the receiver is 1020 meters. The second methodology is human as ground moving target. In this project, 3 persons with different body dimensions were used, and each person will carry out 3 different activities. For the first activity is casual walk, where the target just casually walk through the transmitter and the receiver, and this is the Doppler signature for the casual walk. Next, for pick object, the target have to bend their body and pick object on the ground. So this is the Doppler signature for pick object. And lastly, for up-down step, the target have to step up and step down the stair, and this is the Doppler signature for up-down stair. Continue with the last methodology, which is data processing. The first process is data collection, where the data were collected for 20 seconds in time domain. In data selection, the data will be selected into 5-second time domain, consists of Doppler signature of the activity. Next, fast Fourier transform will convert data in time domain into frequency domain. Next, The power spectral density (PSD) will process all the data in the form of power frequency. Next, all the data will undergo normalization process before it can be classified into their own cluster by using principal component analysis (PCA). Lastly, for data classification process, all the data will be classified into their own cluster, and then the percentage of total classification will be obtained. Let's continue with the result at MyApps. All these figures shows the time domain of person 1, person 2, and person 3 on 3 different activities. As you can see, the casual walk, the blue line, has the lowest time taken compared to pick object, the red line, and up-down stair, the black one. This is because for casual walk, the target have to walk casually between the transmitter and the receiver. But for PO and UDS, the target need to bend their body and step up and down the stair. Besides, the time taken for CW for person 1 and person 2 are quite similar due to their bigger body build compared to person 3. Next, we move to power spectral density. As you can see, peak object, the red line, has the highest Doppler frequency for 3%, which are 2.67 Hz, 1.91 Hz, and 2.10 Hz respectively. This is because the horn antenna, which is the receiver, is set up vertically, so the receiver receives smaller signal for peak object of body cross-sectional area. Next, we move to PCA, principal component analysis. As you can see, all the three clusters do not overlap with each other. Not forget to mention, the blue cluster is for casual walk, the red cluster is for pick object, and the black cluster is for up-down stair. Due to non-overlapping for all the three clusters, the total classification percentage we got at MyApps are 100%. Continue with the result at Campo-Nyalas. For time domain, same as MyApps, casual walk has the lowest time taken compared to pick object and up-down stair. In power spectral density, as you can see, the casual walk has the lowest Doppler frequency compared to pick object and up-down stair, because the receiver receive greater signal for casual walk cross-sectional area. And for principal component analysis, as you can see, the red cluster and the black cluster are overlapping with each other for person 1, person 2, and person 3. This is because due to radar cross-section, and another reason is because the distance between the transmitter and the receiver at Campo-Nyalas is quite far, which is 1020 meters. Next, the total classification at Campo-Nyalas is 80.10% for person 1, 84.52% for person 2, and 88.60% for person 3. Lastly, we go to the result at Teluk Kemang. For time domain, up-down stair has the longest time taken compared to pick object and casual walk. This is because for up-down stair, the target needs to do an extra work where they need to step up and then step down the stair. In power spectral density, same at Campo-Nyalas, casual walk has the lowest Doppler frequency due to greater signal received. Next, in principal component analysis, as you can see, the black cluster are overlapping with both blue and red cluster for person 1 and person 2 respectively. So, the total classification percentage for person 1 at Teluk Kemang is 78.93%, for person 2 is 70.37%, for person 3 is 78.57%. The result at Teluk Kemang is not good compared to Maips and Kampung Yalas due to many interference, example big building and others. Therefore, the distance between the transmitter and the receiver are quite far at Teluk Kemang. As the conclusion, different movement of target can be detected by using passive forward scattering radar system. Next, each person and activities, which are casual walk, pick object, and up-down step, have their own unique Doppler signature. Lastly, passive forward scattering radar can successfully classify all the activities by using principal component analysis by grouping each activities to their own cluster.